Let's look at this example on the equation of a line. So the example says the line M has gradient 5 over 2 and passes through the point 1 minus 2. The line N has gradient minus 2 and passes through the point a half 4. The line M meets the x-axis at A and the line N meets the y-axis at B. Find the equation of the line joining A and B. So before we start this question, let's look at a diagram which represents all of the information given in this example so that we can make sense of the approach that we're going to use to solve this question. So we have a set of axes here, and the first sentence in this example says that the line M has gradient 5 over 2. So the gradient of the line M is positive and it passes through the point 1 minus 2. So if we plot the point 1 minus 2, let's say 1 minus 2 is roughly here, then we know that the line M has a positive gradient, and so the shape of this line should roughly end up looking like this. We're then told that the line N has gradient minus 2, so it has a negative gradient, and it passes through the point a half 4. So if we go across to a half and we go up to 4, then let's say that point is here. Because this line N has a negative gradient, then the shape should look roughly something like this. And so we end up with these two lines here, where this line in red is line N and this line in purple is line M. We're then told that the line M meets the x-axis at A. So here we've got the line M and it meets the x-axis at the point A. So this point here we can label as A. We're also told that the line N meets the y-axis at B. So the line N here in red meets the y-axis at this point, and we call this point B. And so finally, we're trying to find the equation of the line joining A and B. In other words, we need to join these 2 points here, A and B, with a straight line, and we're trying to find out the equation of this line. Now, the way we can do that is we can first work out the equation of the line M, then we can work out the equation of the line N, and then we can work out the coordinates of the point A, work out the coordinates of the point B. Once we've got the coordinates of these 2 points, we can then find the equation of the line that joins the two together. So for line M, we know that the gradient is given by 5 over 2, and so we can label that as M for gradient, which is 5 over 2. We also know that line M passes through the point 1 minus 2. So this is a point that the line passes through, and this point has x coordinate 1, so we label that as x1, and y coordinate as minus 2, so we label that as y1. Now, using the equation of a line where we have a point and a gradient, we have y minus y1 equals to m brackets x minus x1. And all we're now doing is substituting our values in. So we have y minus, our y1 value is minus 2, so we write that in brackets, which equals to m, which is 5 over 2, and then in brackets x minus x1, where x1 is equal to 1. If we now expand the brackets, we get y plus 2, which equals to 5 over 2x minus 5 over 2. And so finally, we can write this in the form y equals mx plus c by taking away 2 from both sides. And so if we do that, we end up with y equals to 5 over 2x minus 5 over 2, and then we're also taking away 2. If we now simplify this, we get y equals 5 over 2x, and so we have minus 5 over 2 minus, so if we write 2 as a fraction where the denominator equals to 2, we have minus 4 over 2, and so this simplifies to y equals to 5 over 2x minus 9 over 2. And this is the equation of the line M. We know that for the line N, it has gradient of minus 2. So M is the gradient, which equals to minus 2. We are also told that the line passes through the point a half 4. So labeling this point, x1 equals to a half, y1 equals to 4. And then using this equation to work out the equation of the line n, we have y minus y1, which equals to m brackets x minus x1. And now substituting our values in, we get y minus 4, which equals to m, which is minus 2, and then in brackets x minus x1, where x1 is equal to a half. If we now expand the brackets, so we have y minus 4 equals to minus 2x, and now minus 2 times minus a half gives us plus 1. And then writing this in the form y equals mx plus c, we add 4 to both sides. So we get y equals to minus 2x, and then 1 plus 4 gives us 5. So we have the equation of the line m, which is this, and we have the equation of the line n, which is this. And now we're told in the question that the line m meets the x-axis at a. And so if the line m meets the x-axis at the point a, then that means that the y-coordinate of a should be equal to 0. And so if we substitute y equals 0 into this equation for line m, we can work out x. So we get that 0 equals to 5 over 2x minus 9 over 2. So that's substituting y equals 0. And now if we solve this for x, we add 9 over 2 to both sides. And so we get 9 over 2 equals to 5 over 2x. And then multiply both sides by 2. We get 9 equals 5x. And so finally divide both sides by 5. And we get 9 over 5 equals to x. So the x coordinate of a is equal to 9 over 5. And the y coordinate of a is equal to 0, since the point A is on the x-axis. We're also told that the line n meets the y-axis at b. So if the line n meets the y-axis at b, then that means that the x-coordinate of b must equal to 0, since it's on the y-axis. So substituting x equals 0 into this equation for line n, we get y equals to minus 2 multiplied by 0 plus 5. And so if we simplify this, we get y equals to 5. Therefore, the point B has x coordinate 0, and the point B has y coordinate 5. To work out the equation of the line joining A and B, we need to work out the gradient of the line, and we also need a point on the line. So A and B are both points on the line, and so we've got that bit, but we need to work out the gradient. Now, to work out the gradient, when we're given 2 points, we can use the following formula. So the gradient m equals to y2 minus y1 over x2 minus x1, where these are the x and y coordinates of 2 points. So we've got 2 points on the line. We can start by labeling this as x1. So 9 over 5 is equal to x1, and 0 as y1. And we can also label the point B, where 0 is x2 and 5 is y2. So substituting these values into this equation, we get the gradient of the line joining A and B is equal to, so y2 is 5 minus y1, which is 0, over x2, which is 0, minus x1, which is 9 over 5. So simplifying this, we get that m equals to, so that's the gradient, 5 minus 0 is 5, over 0 minus 9 over 5, which is minus 9 over 5. And if we simplify this, we get that m equals to 5 divided by minus 9 over 5, which is the same as 5 multiplied by the reciprocal, so that's minus 5 over 9. And so the gradient m equals to minus 25 over 9. So using y minus y1 equals to m brackets x minus x1. So we have the gradient, which is minus 25 over 9, and we have a point on the line, so we could use either a or b and would still get the same answer. In this case, we have y minus, and so let's use the point a. So y1 is the y coordinate of a, which is 0, which equals to m, which is minus 25 over 9, and then in brackets x minus x1, so the x coordinate of a, which is 9 over 5. If we now expand the brackets and we simplify, so on the right hand side we have minus 25 over 9x, and then minus 25 over 9 multiplied by minus 9 over 5 gives us plus 5. And so the equation of the line joining points A and B together is equal to y, which equals minus 25 over 9 x plus 5.